With this program, we want to write a function that receives a text and counts how many vowels are in that text. The reading of the text happens inside the main program. Then the main program calls the function. The function calculates how many times a vowel or vowels are existed in the text, and then prints them like in this example. I'm going to show you two solutions for this. One solution is a solution that just works, but it's not scalable. And then I'm going to present a better, more automated solution. So one easy solution is just to basically have 5 counters, 1 counter for each of the vowel, and then go through the text character by character and have multiple if statements. When we see that a specific vowel, we just add 1 to the counter for that vowel. Let's first implement that easier solution. So define function, count vowels, it receives a text as an input argument. We want to just want version 1 in here as well, just in case. So first thing is the text should consider, the program should consider all uppercase characters and lowercase characters the same. So we can either just use text upper or lower to basically convert them to lower characters, and then basically store it in another variable, or we can just, when we process the text, we can just use it there. If we want to keep the original text, we obviously need to make a copy first if we want to make any modification to text, or if you're not making, if you don't need the text in the original text in our program, then we can change that. But for now, I'm not going to make any change to the text. I'm just going to use it in a loop and then basically count it. So let's define 5 counters. Initialize them by zeros. A counter, I counter, 1 counter for each vowel. And O counter. Then we're just going to process the text character by character. Now we can say text lower. In here. So it doesn't make any change to the text itself. Then all we need to do is to have 5 if statements here. We can say, hey, if this character is A, then increase A counter. If the character is I, then increase I counter, and so on. So if char equals A, then increase A counter. Just copy and paste this again 5 times. Character is I, increase I. If the character is E, increase E counter. If the character is U, then increase U counter. And if character is O, then increase O counter. And then we do this for every character in our text. Once done, we can just go ahead and print the information that we have. for example, A's, A counter. So this is our function in our main program. We're just going to read the text. Then we're going to call the function. Now, let's run it. Let me just make it a bit more compact so I can fit it in the screen. Okay. And when we run it, let's enter a text. Our sample text, some random text here. And you can see, for example, we have two A's, one A here, another A here. 6 E's, 0 I, and U. So this solution works. It doesn't have any problem. There is a little, we can make a little bit more improvements in it. Instead of having 5 separate ifs, that means for each character we're going to have 5 comparisons anyway. We can at least use elif. So, for example, if the character is A, we don't need to compare the rest, the character with I, E, U, and O. So at least we can save some execution times in here, and it's still a little bit of improvement in terms of code. But in terms of scalability, this code is not scalable. So yes, we are finding vowels here, and we have only 5 vowels. But let's say we have a similar situation. You have, for example, a retail store, and in your retail store, you want to count how many special orders have taken place, and you have, let's say, 1,000 different types of special orders, and there are 1 million orders overall. So you want to find in those 1 million orders how many of those 1,000 special orders you have. Those special orders becomes like vowels in here, and the 1 million total order becomes something like this overall text, that the data that we are basically processing. If that's the case, you can have 1,000 ifs and 1,000 countels. So in terms of scalability, this solution doesn't work. What we need to do here, look at here, this piece of code, we're just repeating basically the same thing. We are comparing, counting, comparing, counting, comparing, counting. When we are doing it 5 times inside our loop. Although we are using a different variable, we are counting for different data and then counting in a different variable. But we can easily solve that via the tools that we have in our possession: loops and basically lists. We can easily improve this code and make it completely automated without the need of having 5 comparisons and having 5 separate variables. So let's code the second version. For version 2. So def count vowels version 2. Again, it receives text as an input argument. So the first thing that we need to do is set, hey, vowels, we can put them inside a lists. So A, I, O, U, and A. Then we can declare another list with the same size, 5. That list counts how many times each vowel is basically repeated. So vowels count list this time, and we're going to initialize them by 0. So 5 items of 0, 1 item or 1 counter or 1 list index for each of these vowels. So 1, 2, 3, 4, 5. For example, index 0 of this vowels count list represents how many times I been repeated. Index 2 represents how many times O's have been repeated. Instead of having 5 separate variables in here, we can just put them in one list. Now we can start processing for each character in our text.lower. Then what we need to do is to compare this character with each index of this vowel, which each of these vowels that we have in there inside our vowels list. So we also need to generate these vowels one by one. The way to do it is to use nested loop. So we use vowel in vowels. Now all we need to do is say, hey, if character is equal to vowel, then if this is true, what we want to do is to increase the counter in this vowels count list, the index that associate to this vowel that we are processing. We can use list.index function to return the index of a basically item in a list. So what we say is basically vowels count for index. We're just going to supply vowels dot index of vowel, then add 1 to it. And when it happens, we don't need to compare this character with the rest of the vowels. So we're just going to say basically break. So it breaks from the inner loop and takes the next character. That's basically our function. That's basically our function's job to count the vowels. Once these inner loops, this nested loops structure is completed, then we already have the counts of the vowel. So we can just have another for loop to simply print the information instead of using 5 print statements. So we just say for vowel in vowels, or let's just use index here, I in range length of vowels, then we can say print, for example, vowels and then vowel count I. That's basically our function. So instead of these 5 prints, we just used 1 for loop. And we could do that because we are dealing with lists here instead of individual variables. Now our program is exactly the same, main program. So we're just going to call the second version of this text, and then for input, you're going to enter the same text. Let's see if it works fine. Fix the error. Car. It's a typo here. Car. Again. Vowels I. Again. Yes. It's exactly the same result. Both codes are exactly doing the same thing, but this one is fully scalable. This is not scalable at all. So in programming and in software engineering, it's important to create a product that delivers what we need. But it's also an engineering discipline. That means in order to do that, in order to produce or manufacture that product, we need to follow certain processes that basically gives us the function, the operations that we want, the specification that we want, and also meet certain requirements. For example, performance, or in this case, scalability. So if a code only works, it doesn't mean it's a good code. There's a difference between a software engineer and a good software engineer. A good software engineer is 1,000 times better than for example, an ordinary software engineer, because the product that they create, they are more maintainable, they are easier to scale, they are less complicated, they are basically better.